Professor, Department of EEE, DBS Kavali. So, welcome to Electrical Department to all of you. So, here in this semester, I am going to discuss or I am going to teach you about DC machines and transformers. This is the one of the core subject, one of the main core subject of our department. So that is DC machines and transformers. So actually, this DC machines and transformers subject contains totally 5 units. So in this one, the first unit is actually the magnetic material properties and operations, and next electromechanical energy conversion. But I am not starting that first chapter because I am going to start the second chapter firstly. Why? Because so if you want to understand the first chapter efficiently, you have to know the basic concepts of the DC machines. So that's why I am starting from the second chapter only. Okay. So our second chapter name is DC generators. Okay. The second chapter name is DC generators. So firstly I will go into the contents of this chapter. So here we have some of the contents, that is first one is introduction about the DC generators, and secondly the constructional details of DC machine, and thirdly the principle of operation of DC generator, and fourth one is armature windings and its types, and next one is EMF equation, another one is armature reaction, and another one is effect of brush lead, and demagnetizing and cross magnetizing ampere turns, and we have few more there. In those things, first one is compensating windings, and next one is commutation, and another one is EMF induced in a coil undergoing commutation, and methods of improving commutation, and OCC and load characteristics of different types of generators, and parallel operation of DC generators, DC shunt and series generators in parallel, and equalizing connections. So these are the total contents we are going to discuss in the second chapter, that is DC generators. So first of all, I am going to start the first one, that is introduction. Before going to the introduction, we have some textbooks for the reference. Those are, you people have to follow these textbooks to cover all the syllabus of your subject. That is P.S. Bimra. Book title is Electrical Machinery. Author is Kanna Publishers, and second book is I.J. Nagrath and D.P. Kothari. Book title is Electrical Machines, and McGraw-Hill Education, and few more books is also there to study this subject. Those are Electrical Machines by Bakshi, U.V. Bakshi, B.U. Bakshi. Okay, so many textbooks is there for the DC machines and transformers. So, but in our curriculum, these textbooks added by the university. Okay, so please refer these books to see our syllabus, DC machines and transformers subject syllabus. And coming to introduction, so firstly I am going to DC generator. So our chapter name is also DC generator. So what is meant by DC generator? So I am telling that the definition of the DC generator. So actually the DC generator is an electrical machine, so which converts mechanical energy into an electrical energy, is called an electric generator. Okay, so DC generator means an electrical machine which converts mechanical energy into an electrical energy, so it is called as an electric generator. So actually the electrical machines may be related to an electrical energy of an alternating type, that is AC. Actually the electrical machines may be related to an electrical energy of an alternating type called AC machines, or may be related to an electrical energy of direct type, that is called DC machines. So if the machine is operated by using the AC supply, so those machines are called as AC machines. So those machines which are using the DC supply, those machines are called as DC machines. Okay, so this is the introduction of DC generator. Okay, so here the diagrammatic representation of electrical generator. So here we have some energy, that is the mechanical energy from the fossil fuel, nuclear, hydro, wind, etc. So these are the sources of energy. That means hydro means it is a water, wind means air, nuclear means gas, fossil means some particles. So these are the mechanical energy. So by giving the input of mechanical energy to the prime mover, so this prime mover is easy to drive the generator. So this energy is given to prime mover. So this prime mover is given the mechanical energy to the electrical generator, and electrical generator converts the mechanical energy into electrical energy. So this is the procedure to convert the mechanical energy from electrical energy. So actually, the DC machine is also called as an electromechanical energy conversion. So actually, the study of electrical engineering. So you are electrical engineers. You are the electrical engineering students means. So the study of the electrical engineering basically involves the analysis of the energy transfer. So the study of the electrical engineering basically involves the analysis of the energy transfer from one form to another. So like from mechanical energy to electrical energy, this is one form of conversion. Okay. So an electrical machine deals with the energy transfer either from mechanical energy to electrical energy or from electrical to mechanical. So this process is called electromechanical energy conversion. Okay. So we have different forms of conversion of energy. Okay. So in those we have here in the first chapter we have the conversion of energy from mechanical to electrical. So the conversion of mechanical energy into electrical energy by using a device is called as DC generator. DC generator. So next we have second chapter is DC motor. So the DC motor is used to convert the electrical energy into mechanical energy. So this one is called as a DC motor. So that comes in DC motor concept. Okay. So next one is constructional details of DC machine. So this is the very important topic in this chapter, constructional details of DC machine. So here it shows one diagram. So this is the DC machine construction. So DC machine means either DC generator or DC motor. So for those two machines, so this is the main diagram, the internal diagram of the DC machines or DC generator or DC motor. Okay, this is the construction details of DC machines. So whether a machine is DC generator or motor, the construction basically remains the same. So if you want to explain the construction details of motor means this only, or if you want to explain the DC generator working principle, construction details, so we have to use this only, construction details. Okay. So this diagram, so this is the two-pole machine. So if you see this N and this is a four-pole machine NNSS, that is North Pole, South Pole. Okay, North Pole, South Pole. So here we have one shaft button. Here we have one shaft. Okay. So this one is the field winding. So in poles we are showing the shaded one. This one is field winding. So actually the DC generator or DC motor contains two types of windings. One is armature winding and another one is field winding. So here we are having the field winding in the poles. Okay. Here we have armature winding. This is armature winding. This one is field winding and this one is armature winding and this one is commutator. So I will explain these parts functionalities one by one in the next slides. Okay. This is the overall diagram of construction details of DC machine. So here we have this one is the base. This is the base connection and this circular shapes, outer circular shape is called as yoke. This one is frame or yoke and these are interpoles. So these are the poles and these are interpoles. Okay. And this one is shaft and this one is commutator segments. This one is commutator and this one is commutator segments and this one is shaft. Okay, these are armature conductors or armature winding. Okay, these are the main parts of the construction details of DC machine. So here the list of the parts in the DC machine. So the construction of DC machine can be done using some of the essential parts like yoke. First one is yoke. Second one is poles, third one is field winding, fourth one is armature, and fifth one is commutator, and sixth one is brushes, and seventh one is bearings. These are the 7 essential parts in the DC machine of the construction. Okay, so I will explain one by one by using their functionalities and choice of material. Okay, first one is yoke. So the yoke is also called as a frame. So already you see in the diagram. So this one is yoke or frame. Okay, frame or yoke. So I am explaining about this part. So actually yoke is the another name of the yoke is the frame. So the functionalities of the yoke is it serves the purpose of outermost cover of the DC machine. Outermost cover, that means here this is the outermost cover. So this one is called as a frame. So this one. So this outermost circular shape, this one is called as an yoke. So this is used to serve the purpose of outermost cover of the DC machine. So it protects the entire machine from the moisture and dust. So it covers the entire machine. So that's why we are called as this one as frame. So it protects the entire machine from the moisture and dust, etc. So for example, in all our homes we have photo frames, right? So in photo frame, we have to insert the photo. Whatever we like, that photo is inserted into the frame. Why? So to look better or to protect the photo, your photo. So at the same way, this yoke or frame is used to protect the entire machine from the moisture and dust, etc. Okay. So and it provides mechanical support to the poles. So see this diagram. So these are the poles. So N, there is the north pole, south pole. So this yoke is used to give the mechanical support to the poles. This gives the mechanical support to the poles because these poles are placed on the yoke, depend upon the yoke. Okay, so that's why it provides the mechanical support to the poles. So here we have the choice of material. We have the choice of material. So the materials used for the yoke are designed with cast iron, cast steel, otherwise rolled steel. So these are the materials used in the yoke. Why we are using these cast iron, cast steel or rolled steel means, so actually to provide the low reluctance path, so it must be made up of some magnetic material. Okay, so to provide low reluctance path, so it must be made up of some magnetic material. So low reluctance path means we have to give the excitation, or we have to give the flow of current in the low reluctance path. So to provide low reluctance path, it must be made up of some magnetic material. So that's why it is prepared by using cast iron. So here I am mentioning cast iron, cast steel or rolled steel. So here we are using cast steel because it is cheapest among cast steel and rolled steel. Compared to these two, cast iron is the cheapest metal. Okay, so it is prepared by using cast iron because it is cheapest. So for large machines, we are using rolled steel, cast steel or silicon steel. Okay, why we are using these materials? Because it is used to which provides high permeability. Permeability means low reluctance and gives good mechanical strength. Permeability means it gives low reluctance path and also it gives good mechanical strength to the part component. Okay, so here we are using cast iron, cast steel, rolled steel, silicon steel. Okay, so these materials. So the cast iron is used because it is cheapest among these. But for large machines we have to use the rolled steel or cast steel or silicon steel because it provides the high permeability to the particular part. Because permeability means it gives a low reluctance path and it gives good mechanical strength to the component. That is for yoke. Okay, so this is the yoke, and next one is poles. So actually, the pole of the DC machine is an electromagnet. So already you see in the diagram, that is, so these are the poles. So north pole, south pole, and interpoles. Okay, these are the different poles. Okay, so the pole of the DC machine is an electromagnet. Okay, and the field winding is winding among pole. So if you see this diagram, so this is the field winding. So these field windings is wound on the poles. So these are the field windings. Okay, so these field windings are wound on the poles only. Okay, next. So whenever field winding is energized, then the pole gives magnetic flux. So whenever the field winding is energized, then the pole gives magnetic flux. Okay, actually each pole is divided into two parts. Okay, each pole is divided into two parts. Here we can see the two parts, that is pole core and pole shoe, and this one is the yoke. This is the internal diagram of the pole. This is the pole structure. Okay, this one is the pole structure. We have each pole is divided into two parts. Those are pole core and pole shoe. Okay, so here the functions of pole core and pole shoe is, so if you see this diagram, so we have pole shoe. This one is pole shoe. So actually this is the pole. So but this part is called as a pole shoe. This one is called as a pole shoe. Okay. So pole core. Actually this one is called as pole core. So this one is pole shoe and this one is called pole core. Okay. So if you see in the pole, this one is the pole core and this one is the pole shoe. If you see, if we imagine this is a pole, this one is the pole core and this one is the pole shoe. Okay. So here we have to know the functionalities of pole core and pole shoe. So here the functions of pole core and pole shoe. So pole core actually carries a field winding. So already I shown that one. So pole core basically carries a field winding. So which is necessary to produce the flux. Okay, pole core basically carries a field winding. Carries which carries a which is necessary to produce the flux. Okay, actually this pole core directs the flux. So pole core basically carries a field winding which is necessary to produce the. So it directs the flux produced through air gap to armature core. Okay, it's the flux produced through air gap to armature core. So actually in every machine we have some air gap. Okay, so this here also we have one air gap. So it directs the flux produced through air gap to armature core to the next pole. So that means, so if you see this diagram, so it directs the flux produced through air gap. So here if the flux is produced means it is directed through air gap. So from this way to it goes into the next pole. Okay, so it directs the flux produced through air gap to armature core to the next pole. So this way to this way the flux is moving from here to here, from the air gap, okay, to the next pole. Okay, so next, pole shoe. So actually this pole shoe enlarges the area of armature core. Why? Because to come across the flux. So pole shoe enlarges the area of armature core to come across the flux. Hello. So pole shoe enlarges the area of armature core to come across the flux. So this one is used to, so which is necessary to produce larger induced EMF. So actually pole shoe, so this one, so this pole shoe is used to enlarges the area of armature core to come across the flux. So which is necessary to produce larger induced EMF, so which is necessary to produce larger induced EMF. So to achieve this, pole shoe has been given a particular shape. So if you want to achieve this functionality, actually this pole shoe, the pole shoe has been given a particular shape like this. So this is the shape of the pole shoe. So this is the shape of the pole core. So if you want to go to pole shoe, which is necessary to produce a larger induced EMF. So to achieve this, pole shoe has given a particular shape. Okay. Next one is this is the functionality of pole shoe and pole core, and the next one is choice of material. So actually this pole shoe and pole core is made up of magnetic material like cast iron, cast steel. So already in the yoke also we are using cast iron and cast steel. So here also we are using cast iron and cast steel, and it requires a definite shape and size. Why it requires definite shape and size? To enlarge the necessary of flux, production of flux. So this point, so which is necessary to produce the larger induced EMF, and to enlarge the area of armature core to come across the flux. So that's why we are it requires a definite shape and size, and laminated construction is used. Okay, so why we use laminated construction means, so the to reduce the losses. Actually I will discuss about the losses in the next classes, next coming classes. The laminations of required size and shape are stamped together to get a pole which is then bolted to the yoke. So laminations are required. Laminations also have to require a shape and size together to get a pole which is then bolted to the yoke. Okay, so that means this one. So if you want to fix the pole to the yoke means we have to have a specific size and shape. So the laminations of required size and shape are stamped together to get a pole which is then bolted to the yoke. So this is the constructional details of DC machine up to now, and in the next class I will discuss the next parts. Okay.